So hello everyone, I am Jaishree Jain from AKGEC Engineering College, Ghaziabad. Today we will discuss about the Hadoop and MapReduce technology. So in cloud computing, we all know due to the central server, the data is going to upload over the cloud. So there is very large amount of data which is going to be stored over the cloud. So we have to use some technology that can manage this type of big data. So the Hadoop is one that is used to maintain the data over the distributed server, and how can we manage this large amount of data over the network, that is cloud network, that is very broad network. So Hadoop is a technology, or we can say a distributed file system, which will help to maintain the large amount of data, like it can be any 5 exabyte data or terabyte, such as Facebook and Instagram and other social media site are going to use this technology. So we will understand what is Hadoop and how it works, what is the architecture of Hadoop, and what is the methodology, how can it manage the big data in over the cloud server. So this is a symbol of Hadoop. This small elephant have the reason. The developer of Hadoop is uh, these are the developer of Hadoop technology, like Michael Carella and duck cutting. So the symbol of elephant is taken by her son, have the toy elephant, and he does give the symbol of elephant to the Hadoop technology. So we will understand what is this. Apache Hadoop software library is a framework that allow for the distributed processing of large data set. So we all know in a single processor system we have a single hard disk, and hard disks have different sectors, and there are different track. So we tied to a single storage system, but when we have the cluster of computer over the cloud, so how can we manage or process that large data set across the cluster of the computer? So it have the library framework which allow the distributed processing of large data sets, and it is made by the Apache Software Foundation in 2011. So the server that is made developed, that is Apache Software Foundation in 2011, and that is written in Java. So this software is designed in Java language, and it is a major foundation is Apache Software Foundation in 2011. So what is Apache Hadoop? So we can say this is a open source software framework that is designed for storage and processing of large data set on the cluster of commodity hardware. So basically, as we know, in the cloud we have the shared hardware, and over the server we are getting the hardware as a resource, as a service. So these all the services, when we use these services, then these services are used as a for processing of our data. We also need some storage so that we can process this large scale data over the cloud. So this is the open software framework that will provide the user. User can take the service of Hadoop, so that any cloud service provider can make the storage more and more storage that is beneficial to the user to maintain the big data. So this is the about the Apache Hadoop, created by Doug Cutting and Mike Carella in 2005, and Cutting named the program after his son toy elephant. So this is the theory about this. These are the developers of Hadoop technology. Next, these are the famous users, or you can say customer or vendors, which are going to use the Hadoop, like Facebook, IBM, Twitter, Apple, Google, and HP. So these all the vendors are going to use this Hadoop services. So basically, what are the application or uses of Hadoop? We can use the Hadoop software for data intensive text processing, as we have we know there are the WhatsApp we are using for sharing the text. So all kind of data, all WhatsApp data is going to store over the server. So we have to use the Hadoop technology, assembly of large genome. So in case of we are doing some project on genome analysis, or in healthcare industry, there is a use of Hadoop, graph mining, machine learning, and data mining. So this is very important because we have a large data warehouse which have historical data and as well as current transactional data. So we have to use the we have large amount of data, so large storage of data is required. Large scale of social network analysis like Facebook, Instagram, and all that. So these all are the uses of Hadoop. And who uses Hadoop? Like these are all the vendors which are going to use this service: Samsung, Yahoo, and all, Netflix. So all these are the examples or users which are which have the need to manage their large amount of data over the network. So these are the Hadoop users. Motivation for Hadoop is what were the limitation of the earlier large scale computing. So why we need the Hadoop technology? Because we all know before the development of this technology, we have the distributed system in which we are try to divide our work over the different processors so that we can execute the task parallelly, and we can divide the task and can save the time. But that technology is very complex, and when the system will going to execute parallelly, there are some clashing also. How can we sync the events? So there were the synchronization problem in distributed system, and fault tolerant are also the problem in that system. So limitations are very important for this technology to be developed. And next is what requirement should have an alternative approach we can develop. So alternative approach is what? Hadoop. And how does Hadoop address those requirements? So we have to understand with why we are going to use the Hadoop technology and what is the purpose, what purpose is going to solve by using the Hadoop technology. So early large scale computing is what? Historical computation was processor bound. So processor bound means data volume has relatively small and complicated computations performed on that data. So system are processor bound because we have one PC and we are going to perform that task on that PC. So we have limited space, and for complicated computation it will take very much time, and it will be less efficient. So advances in computer technology has historically centered around the improving power of a single machine. So all the scientists or developer have worked on this requirement so that we can process our complex task, and it will be efficient. So distributed system, we all know that allow the developer to use the multiple machine for a single task. And the problem in distributed systems are programming on a distributed system is complex, as synchronizing data exchanges is a problem, managing a finite bandwidth. So it will be very complex. So because data is distributed over the server, and how can we synchronize the event? How can we if any user is going to add it on some data, so how can we ensure that we are going to work on the new data set? So which data will be finalized? So there are various problems. Controlling computation timing is complicated. So I already discussed that it will be very time taken process. So how much data we have, if we are talking about Facebook, it have 500 terabyte per day. For example, Yahoo over 170 petabyte, eBay is going to transact over 6 petabyte of data. So getting that data to the processor become the bottleneck. So how can we handle this large amount of data? So we can say this is one kind of big data. Big data is a term that used to define very large amount of unstructured or semi-structured data that a company creates. So the term is used when talking about the petabyte or exabyte of data. So that much data would take so much time and cost to load into the relational database. So before we have old technology, we have the relational database like Oracle or SQL Server. So how these all kind of database software have want the data in structured format. So what about if we have the large amount of unstructured data? So Facebook has almost 10 billion photo taking up to 1 petabyte of the storage. So this is a cumbersome problem. So what is the problem? Processing the large data is very difficult in relational database, and it would take much time to process the data and cost. So we can solve this problem with the help of distributed computing. But the problem is in distributed computing. Now we can see what are the different problem in distributed computing. First is the hardware failure. So chances of hardware failure is always there. So we all know if we have connected various system with the one server, and there are client server system. So if one client is going to fail, then we can say the data the data can be lost. So this is the one kind of disadvantage of this technique. Combine the data after the analysis. So this is the second problem. Data from all the disk have to be combined from all the disk, which is a mess. So I already discussed, if we have divided our task on the different system, and when we are going to process that data, so we have to merge that data and we have to combine that data from all the servers or all the client systems. So this will be a mess. How can we finalize the final data? So requirement is for Hadoop that must support the partial failure, and it should also be scalable. So to solve this problem, Hadoop came, and it has two main parts: Hadoop distributed file system and MapReduce framework. So we understand what is Hadoop distributed file system and what is the MapReduce technology. So Hadoop is, the core idea was to distribute the data it is initially stored. So in Hadoop, basically we divide the data to all the systems, so that each and every system is going to operate on its own data. So the core idea was to distribute the data. Each node then perform the computation on the data that is stored on that node only, means on that cluster only, that is without moving the data from the initial processing. So we need not to recollect that data on the central server. Each client have its own data center, and each client is going to operate on that data that is assigned to that client, or that is stored on that node. So when data is loaded into the system, it is divided into the block. So firstly we are going to divide our data into the block like 64 MB block or 128 MB blocks. Then tasks are divided into two phases: map task and reduce task. So there are two technology. First is the map task, which are done on the small portion of the data. So firstly we divide our data into the blocks, and then we divide or map the task into that data node. After that we used to reduce the task, which combine the data to produce the final output. It means firstly we have different node, and we divided our data into the blocks and assigned that data to that node. After that we have to perform some task on that data. So we will map that task to the slave node. There is one master node and there are several slave nodes. So master node will assign the task or map the task on that data node, and at the last all the tasks going to be combined in the master node. So reduce the tasks that combine the data to produce the final output. So master program allocate the work to the individual nodes. And this Hadoop, we can say this is fault tolerant technique, as failure are detected by the master program, which reassign that work to a different node. So this is the duty, or this is the task of the master node. If there are different slave node and one node is going to be failed, then that program will assign to be, that task will assign to be on different slave node. So restarting the task doesn't affect the node working on the another portion of the data. So that task will be going to be restart if one node going to be fail, and if fail node restart, it is added back to the system to assign the new task. So if we repair or we repair that node, then it will back added to that master node. So master can redundantly execute the same task to avoid the slow running node. So what is Hadoop distributed file system? We can say it is a distributed file system. Obviously, we going to divide the data into block and map the task into that block. Traditional hierarchical file organization. So the file organization is same as we have on our single file system. Single namespace for the entire cluster. It means we have the single database, but we have divided that data into the number of blocks. Write once, read many access model. So this model is write once means we assign or map the task into that data node, and that will be freezed, but it can have the we can repeat that block for the read purpose. Aware of the network topology. Network topology can be any one, that can be mesh topology or star or bus topology. So responsible for storing data on the cluster. So we can say Hadoop is responsible for storing the data over different cluster, and files are split into the block and distributed across the nodes in the cluster. Each block is replicated multiple times, as I already told that if the block is going to be write once, that it can be replicated for read purpose. And the basic concept is what Hadoop distributed system written in Java based on the Google GFS system, and provide the redundant storage for massive amount of data. So that obviously that data is having the redundant storage, because we are going to reduce the task and we merge the task by having the map reduce technology. So we will understand what is the map reduce concept. So basic concept is what Hadoop SGFS works best with the smaller number of large file, million as opposed to the billion of file, and typically 100 MB or more per file. So we divide the data into the number of block, and the block size can be of 100 MB or more. Files in Hadoop system are write once and optimized for streaming read for large file and not random read. So we will accept the request if anyone want to read that data that is already right. So this is the architecture of Hadoop, high level architecture. We have Hadoop client which have contact name node for data and job tracker. There are two nodes are there. First is the name node and second is the job tracker. So name node is what where we try to map the divide the file into number of block and assign that block to the slave node. And this job tracker, that is used to schedule the job across the task tracker, means what kind of operation we want to perform on that data, that will be tracked by this job tracker, and the task will be performed on the slave node. And there we have data node. This is a part of slave node where this data is going to be mapped, and task tracker that run on the that perform the task on that data within the job. So this is the architecture, and we understand the loop here. What is the role of master node and slave node? So we have 4 tasks here: data node, job tracker, task tracker and name node. So we can see here we have master node and slave node. So on master we have the job tracker, and job tracker will divide the task into the different slaves, like task tracker here, and task tracker is on the slave node. And here we have the data node, and on the data node we divide the data node into number of block. So this is the one block, that is name node is the one fixed node, and here it going to map the data into the different data nodes. So at slave node, we have the data node and we have the task tracker. So this is a Hadoop cluster. This is one Hadoop cluster, and we have a Hadoop distributed file system name node feature. So what kind of metadata that name node contain? The name node contain about the list of files. Like this name node will contain what kind of metadata? There are list of files, list of blocks, list of data nodes for each block, and file attributes are also there, creation time, records every change in the metadata. So these all kind of information is going to contain into the name node. So how it will work? When we are going to combine that data from the different slave node, this is a primary name node and this is a secondary name node. So at primary name node, it have the RAM and hard disk, and its first step is pull transaction log. So all the log of that file that is stored in that RAM is going to be pulled on the secondary name node, and here it going to merge the changes. So what kind of changes are performed on that data? That will be merged at this point, and this is going to be saved into the hard disk. So that data is going to be stored on the hard disk drive. After that, the slave master node will push all the changes. The final file is going to be pushed on the master node name node. So this is the working how Hadoop file system will work. And what about Hadoop system data node? So data node is block server that stores the data into the local file system. So data node is we have data node here. We have discussed what is the working of name node. Now what is the working of data node? So data node will work that store the data into the local file system, periodic validation of the checksums, and periodically sends a report of all the existing block. So what kind of task is going to perform on the data node? Data node will have the report of all the existing blocks to the name node. So it will give the report to the name node, and periodic validation of the checksum or block server that stores the data into the local file system means it will store the data onto the RAM, and after that RAM is going to store that data into the hard disk drive. Next is MapReduce. So MapReduce technology, how it will work? It is a programming model for processing and generating the large data sets with parallel distributed algorithm. So what is the need of MapReduce? Actually, this is basically required when we are going to divide our data into number of blocks, and when we are going to merge that data node into the name node. So it is an associative implementation for processing and generating of large data set. So map function that process key pair to generate the set of intermediate key pair. So there are two functions, map and reduce. Map function that process the key pair. So key pair means if there is a key that is associated to the all the data nodes, and reduce function that merge all the intermediate value that is associated with the intermediate keys. So firstly we assign one key value to all the data node, and when we are going to merge that data node, we match the key. If the data node have the same key, then that data is going to be merged into a single file. So this is the framework. MapReduce implementation is we have job tracker and we have task tracker. So job tracker will going to splitting into the map and reduce the task, scheduling the task on a cluster node. So here we have job tracker in master node, and in master node we have the job tracker, and on the slave node we have the task tracker. So it is going to divide. This will going to analyze or track what kind of task is going to be performed here. So this job tracker is going to split into the map and reduce the task, and this task tracker run the map reduce task periodically. So firstly we have the input data, then we perform the map function here, to divide the data into the block and assign one key to each and every block of data, and then we apply the reduce function by mapping all the key and reduce the data, and finally we have the output data. So there are three functions split into the map function, then we are going to sort according to the key, and then we are going to merge if the keys, like if we have k1 key and data nodes are v1, v2 and v3 with having the same key, then it is going to be merged. So there is a mapper that reads the data as key value pair. So we have to read the key, and with respect to that key we have to read the value or date of data node. So the key is often discarded and outputs 0 for more key value pair. So if we have the same key, we are going to merge that data, or if there is the no key associated with that data, then output will be 0. Then shuffle and sort. Output from the mapper is sorted by the key, and all value with the same key are guaranteed to go with the same machine. And the reducer is what called once for each unique key, that is all the key will be called and get a list of all the value that is associated with that key as a input, and the reducer output 0 or more key value pair, usually just one output per input key. Means if we have the same key associated with that data node, then we only merge that data and assign the final key to that data. So this is a basic example. If we have input data like deer, beer, river, car and river, deer, car and beer. So we first task is to split the data. So we have split the data, that is one data node, second data node and third data node. After that the mapping function is there. We assign the key to each and every data node. So we assign 1 to this data node, and again we assign the 1 to this data node because they are on the different clusters. After that we are going to shuffle. If we have the same data, like beer is here and beer is here, so we do the shuffling according to the value of the data. So the value of the data is same and key is going to be read here. After that we are going to reduce that data. If we already know this kind of data have the two values, so we merge that data and assign the key 2. Means this data is can be read twice, or it can be write 1 and read 1. So we have assigned the key 2 here, and car having the value 3, deer having the value 2 and river having the value 2. After that we have the final result on the master node. So we collect the data, beer having the key value 2, car 3, deer 2 and river 2. So this kind of unstructured data or big data is going to tackle like that way, and finally we have the data after having the key value also associated with that data, so that we can understand how much time the data is have the write or read operation on that data. So benefits of Hadoop is cost saving and efficient reliable data processing, provide the economically scalable solution. So data can be in very large amount, but we can easily handle that data. Storing and processing of large amount of data is there. Data grid operating system, as we already know, there are different clusters of the node, so it will support the grid operating system. It is deployed on the industry standard servers rather than expensive specialized data storage system. So we need not to deploy the large data center, we can only use that server, and with the help of server we can manage the data. Parallel processing of huge amount of data across the inexpensive industry standard servers. So these are the benefits of Hadoop, and basic pros of Hadoop is computing power will save, flexibility is there, fault tolerance, low cost and scalability. These all are the features of Hadoop system. And the cons of Hadoop are integration with the existing system as Hadoop is not optimized for ease of use. Installing and integrating with existing database might prove to be difficult. So if we are going to, because it is open source software, we are going to install the Hadoop. So our database might be difficult to handle the data, especially since there is no software support provided. So as we know, for installing the Hadoop in our system, basically there should be a large storage, should be free in your system, or large amount of hard disk is required. Administration and ease of use, this is the second disadvantage. So Hadoop require knowledge of MapReduce or significant training, and security issues also there can be lack of security functionality. So thank you so much.